Hello everyone. In this short video lesson, we will see three problems from the theory of sets. The first problem, if A without B contains 1, 2, 3 and A without C contains 1, 2, 4, then find A intersection B intersection C complement. You are given the relative complement of B with respect to A containing three elements 1, 2, 3. The relative complement of C with respect to A 1, 2, 4. Based on these two, find A intersection B intersection C complement. Now when we say it, it seems ambiguous, but when we apply the properties of set operation and the properties of complement, you can easily find A intersection B intersection C complement based on the given information. So let's start from A intersection B intersection C complement. Now this is equals to A intersection B complement union C complement. Remember De Morgan's law? B intersection C complement will be what? B complement union C complement. So from De Morgan's law, we can change B intersection C complement into what? B complement union C complement. Again, this is equals to A intersection B complement union A intersection C complement. Why? What do you think the reason behind? A intersection B complement union A intersection C complement. I hope you know the answer, because intersection is what? Distributive over union. You can distribute intersection over what? Union. Just multiplication is distributive over addition. You can distribute intersection over what? Union. That means A intersection B complement union A intersection C complement. And again, from the property of complement, A intersection B complement is what? A without B, elements in A but not in B. And A intersection C complement is the same as A without C, elements in A but not in C. So we can replace A intersection B complement by A without B union A without C. Already we have these two. So the union of A without B and A without C, the union of these two sets will give us elements in A intersection B intersection C complement. So the union 1, 2, 3, 4. When you apply De Morgan's rule and the properties of intersection and union, you can easily solve the problem. Now the second problem we have, suppose A, B, C are what? Sets. Say that A is a subset of B and B is a subset of C, with set C containing numbers 0 up to 9, and C without B, elements in C but not in B, are given 2, 3, 5, 7. So these elements lies in C but not in B. Set A is given containing 0, 4, 8. Now based on this given information, you are required to find elements only in B but not in A. Now first, B is a subset of C, and at the same time, elements only in C but not in B are given. That means from the concept B is a subset of C, we know all elements of B are in C. At the same time, you are given elements only in C but not in B are what? 2, 3, 5, 7. So from these two, you can conclude B will contain elements from C other than what? 2, 3, 5, 7. So when we reduce 2, 3, 5, 7 from C, you will get what? 0, 1, 4, 6, 8, 9. So in this case, B is a subset of C. All elements of B are elements of C. And the only elements in C but not in B are what? 2, 3, 5, 7. So when you reduce 2, 3, 5, 7 from set C, it will give you what? Set B. Now we have set B and set A. Therefore, elements in B but not in A will be what? 1, 6, and 9. 1, 6, 9. These are elements in B, but not in A. Now the third, which is word problem. Out of a group of 100 households, 60 of them have TV and 75 of them have Wi-Fi, and 40 have both Wi-Fi and TV. So the question is, how many of them have neither Wi-Fi nor TV? So to find this, first, let T stands for the set of households who have TV, and capital W stands for the set of all households who have what? Wi-Fi. So based on the given information, the number of households having TV, 60, the number of households having Wi-Fi, 75, the number of households having both TV and Wi-Fi, 40. So based on these three information, we can find the number of households having TV or what? Wi-Fi. N of T union W. So from the formula, this equals what? N of T plus N of W minus N of T intersection W. So N of T is given, which is 60, plus 75 having Wi-Fi, minus the sum of these two minus 40, it gives you what? 95. So the question is what? How many of them have neither Wi-Fi nor what? TV? What do you think? We have a total of what? 100 households. Those having TV or Wi-Fi, 95. So 100 minus 95. 5 households will have neither of the two. So based on formula, the number of elements of T union W complement. T union W complement means households that have neither Wi-Fi nor what? TV, which is equal to the total number of households, 100, minus those households having TV or Wi-Fi, 95. So 100 minus 95, we have what? 5. And again, we can demonstrate this concept of set based on the Venn diagram. Just the rectangle represents the total number of households. Within the rectangle, the first circle represents those having TV. How much? 60 have what? TV. Out of 60, 40 have Wi-Fi too. So 40 is the intersection of those having TV and Wi-Fi, and 20 will be what? Those households having only TV without Wi-Fi. So 20 plus 40, you have total 60 households having what? TV. And having Wi-Fi, 40 plus 35, 75. So among 75, when you subtract 40, 35 households have only what? Wi-Fi. Wi-Fi without television, 35. TV without Wi-Fi, 20. So total T union W, 20 plus 40 plus 35, that gives you what? 95. So 95 households have TV or what? Wi-Fi. Neither of these two sets, that is what? 5. The number of elements in T union W complement, that are what? 5. So based on Venn diagram, we can describe this word problem. This is one of the importance of Venn diagram. We can demonstrate ideas in set theory based on the Venn diagram. So I hope you understand the concept. So if you have problems regarding the concept in these 3 problems, you can see my video lessons 7 and 8. In the video lesson 7 and 8, I try to explain the concept of set relation operation and also Venn diagram. And please subscribe my channel and turn on the notification bell so that you get notification when I release additional video lessons. Thank you and